in one of the earlier sections on quadratic equations, I would give you an equation like this and then ask you to sketch this graph. So you would then say to yourself, when x is small, it wants to do this here. So when x is small, it wants to do this straight line here. So the intercept would be -6. Let's guess -6 to be around here. It wants to do a gradient of -4, so it will look something like this. And then when x is big, it wants to do a positive quadratic. So it wants to do a positive quadratic, so it will look something like this. So your sketch will look something like this. And then to find out the lowest points, to find out the turning point, we would then have to complete the square. So starting out with our equation here, we would then have to complete the square. That would take us to this. Okay, so I've done a whole section on completing the square. So if you don't understand this bit here, then watch this section. Watch one of the earlier videos. So to complete the square, we would zoom into these two terms here and try to create these two terms. We always need half of this, so that would give us a 2 here. And then we would then immediately take away the rubbish and then carry the -6 down here. Okay. Again, I've done a whole section on this. So blah 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 blah. It would take you to here, and then to find the lowest point, we would then ask ourselves, when would this whole thing here be at its lowest point? It would be at its lowest point when you put +2 into here. So y is at its lowest point when x equals 2. Okay, so we can always use completing the square to find out the lowest point of the quadratic. But here's an alternative method. We can use calculus to find out this point here. So here's an alternative method. So you would start out with your equation here. You would then sketch your graph like this here. And then, but here's the thing: the turning point here, or the lowest point here, is when the gradient is 0. You see, if you sketch your graph, it will look like this. Looking at this point here, the gradient's negative, gradient here is negative, the gradient here is negative, but it's getting shallower. Now the gradient right at this point here. The gradient right at this point here is actually 0, and then here is positive, here is positive, and here is positive. So when starting out with your equation, you differentiate it. That would then give you this here, and then when you sketch the graph, when you sketch this graph here, it will look like this. It will look like this. Okay, so your original graph looks like this. And your dy by dx will look like this. You see, the turning point, which is at 2 here, the turning point is when the gradient equals 0. So now looking at the gradient, when would this thing be at a 0? Will be 0. The gradient's 0 right at this point here when x is equals to 0. So an alternative method to finding out the lowest point is to think. When you look at this graph, think in terms of dy by dx. Think in terms of the gradient. At the turning point, the gradient will be 0. So work out the gradient and then find out when this thing here will be 0, and then that will indicate the turning point of this graph here. Okay, so here's an example here. So when given a graph like this, you see, now think in terms of the gradient. If you look at this point here, the gradient's positive, 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 and then there comes a point when the gradient is 0, and then the gradient here will be negative, 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 and there will come a point where the gradient will be 0 here. So there should be two turning points here. Okay. Now think in terms of the gradient now. So this was your original graph. Differentiate it, it will give you this. So dy by dx is this blue line here. Now, when the gradient is 0, which is this point and this point here, that's when now jump back to your normal graph here. That's the turning point there. Now, inside your mind, jump back to to the gradient graph. The gradient graph is 0 right at this point here. Now jump inside your mind, jump back to the original graph, which is a red line here. You see that this here is a turning point here. So when given a graph like this, to find out the turning points of this red line here, then you would differentiate it, and then find out when the gradient equals 0. The gradient equals 0 would indicate when the red line will have its turning point. So yeah, so the trick here is to start out with this, differentiate it, and then find out when this equals 0. Okay, so start out with our original equation here. So hang on. So this was our original equation here. So yeah, this is our original equation. Differentiate it. It will then give you this. Okay, so if you differentiate this, it will give you this here. Now find out. So then quickly sketch this graph here. When x is small, it wants to do this thing here. So we'll have an intercept of 2, a gradient of -6, and then it wants to do a positive quadratic. So it will look something like this. Now find out when this thing here equals 0. Well, the gradient is 0. Yeah, find out these 2 points here. And to do that, you would then well, so you start out with your equation here, differentiate it, it will give you this, and then say to yourself, when you differentiate it, you will get to this stage here. Try to find an x when the gradient will be 0. Finding an x when the gradient is 0 is you setting dy by dx to 0. So it's you doing this here. You're trying to find the whole thing here that will give you a gradient of 0. So it's really a matter of you finding out x, the value of x when the gradient would be 0. So here you would then divide everything by 3, and there are lots of ways of doing this. You can use the quadratic equation, but the method that I've taught you so far is to divide everything by 3. That will so divide this by 3, divide this by 3, divide this by 3. That will give you this. Okay, and then so it's you completing the square here now. Concentrate on creating this. You will need half of this, which is a 1 here, and then immediately get rid of the rubbish, and then carry this down. Okay, and again, if you don't understand this bit here, watch the section on quadratic equations, and then blah 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 here, blah blah blah. Yeah, so single number here, merge these two together, it will give you this. Okay, and then add this block to both sides. That will then give you this, and then square root both sides. Square root both sides. That will then give you this, and then add 1 to both sides. So x equals this. So x equals 1 plus and minus root a third. So you know that, well, if you work this out, x here, if you get a calculator and work this out here, this here will be your first value of x, this here will be your second value of x. So now to find out this point here, you would get this value here, put it into the original equation, okay, and then work out the whole thing here. This whole thing here will give you the y value here, which is this value here. So the coordinates at this point will be here. Okay, and then because this is your this value here will make your dy by dx equals to 0. So you would then put this into here, and then into here, and then into here, and then the whole thing here would equal this. Okay, so that's so the trick is to hang on. The trick here is to so when you have your original equation here, differentiate it, and then find out when the gradient equals 0, and then when you've got your x value of when this dy by dx equals 0, you can then put it into the original equation to find out the y value. Okay? I hope you understand.